Welcome to the special Certified Plus training presentation on base brake fundamentals. Viewing this video presentation is a prerequisite to the Training Center Hands-On Base Brake Systems course number 15,000.01. This presentation will focus on some of the most important base brake service procedures. To help you better prepare for the Hands-On Training Center course, the booklet accompanying this videotape is the same booklet used in the Base Brake Systems course. Properly performing all base brake repairs is critical not only to customer satisfaction, but to overall customer vehicle safety as well. Therefore, during this video presentation, we will thoroughly review the following base brake service procedures: the brake pedal travel check and pressure brake bleeding, master cylinder overhaul, brake pipe flaring and bending, brake drum and brake rotor measuring, drum brake service, brake lathe setup and operation, and front disc brake caliper overhaul. All of these service procedures, as well as others, are further covered in course number 15,000.01, Base Brake Systems. Let's begin by looking at the brake pedal travel check procedure, as well as the pressure brake bleeding procedure. A customer concern of extended brake pedal travel might be a reason for performing either of these. The brake pedal, which is connected to the master cylinder, actuates the brake system. The brake pedal and linkage also provides a mechanical advantage, which is typically a 5-to-1 ratio to assist driver application. Brake pedal travel is simply the distance the pedal moves toward the floor from a fully released position. Use a brake pedal effort gauge, such as J28662 or equivalent, to assist in measuring brake pedal travel. This check should be made with the brakes cold and the engine off. Attach the pedal pressure gauge and apply the brake pedal at least 5 times with the engine off to remove vacuum from the booster before performing the check. If the vehicle is equipped with tilt steering, make sure that the steering wheel is in the centered position. With a yardstick, measure the distance from the bottom of the steering wheel to the top of the brake pedal. Take the first measurement with the brake pedal released. Be sure to write down this number. You will need it to calculate the amount of pedal travel. Now apply the brake pedal with about 445 newtons or 100 pounds of force as indicated on the brake pedal effort gauge. Be sure to press firmly on the center of the gauge to obtain an accurate reading. Take the second measurement using the same reference spot on the steering wheel. It is important to take the second measurement using the same location on the bottom of the wheel where the first reading was obtained. Write down this number and subtract measurement 1 from measurement 2. For example, if measurement 1 was 20.50 inches and measurement 2 was 22.75 inches, the measured brake pedal travel would be equal to 2.25 inches. Compare this measurement with the specification in the service information. If the brake pedal travel is excessive, refer to the brake system diagnostic chart. Air in the hydraulic system could also lead to a customer concern of a low or spongy brake pedal and inefficient brake application. Pressure bleeding the brake system is one way to eliminate air from the hydraulic system. Use the Kentmore diaphragm brake bleeder, J29532 or its equivalent, to perform pressure bleeding. Begin by installing the correct bleeding adapter to the master cylinder. Ensure that the pressure bleeder tank is at least 1/3 full of clean DOT3 brake fluid. Charge the pressure bleeder air tank to specification. Attach the hose from the pressure bleeder to the master cylinder bleeder adapter. Open the pressure tank fluid valve and inspect for any leaks. Begin bleeding at the right rear wheel circuit. Open the bleeder valve at least 3/4 of a turn and allow the fluid to discharge into a clean and clear container until the bubbles stop flowing from the bleeder tube. Then close the bleeder valve. Continue this process at the remaining wheels until all the air has been bled from the system. Close the pressure tank fluid valve and disconnect the bleeding equipment as well as the adapters. Refill the master cylinder reservoir and replace the cap. On vehicles with a combination valve, it is necessary to hold the valve stem of the metering valve open manually when pressure bleeding to allow fluid to flow to the front calipers. To do so, push the valve stem in using no more than 25 pounds of pressure. Excessive pressure may damage the valve. Use tool number J39177 to hold the valve stem open. Do not use a screw clamp, wedges, or blocks because they may put excessive pressure on the valve stem and cause damage. An internally leaking master cylinder could be the cause of a customer concern where the brake pedal slowly falls to the floor while the vehicle is stopped. In this situation, overhauling the master cylinder is probably needed. But before we look at the overhaul procedure, let's quickly review function and design of the master cylinder. The master cylinder contains two pistons, each connected to a hydraulic channel. The primary piston, or rear piston, is operated by the brake pedal linkage, and the secondary piston, or front piston, is operated by the primary piston. The pistons pressurize the brake fluid in the hydraulic channels to each wheel brake. Before beginning a master cylinder overhaul, it is important to realize that you must not hone the master cylinder bore. It is recommended that the cylinder be replaced rather than cleaned up by honing the bore. The master cylinder has a hard, highly polished, bearingized surface. Honing will destroy this hard, smooth surface and cause rapid wear of the rubber seals. To begin the overhaul process, first remove the cover, followed by the diaphragm. Then carefully drain the brake fluid from the reservoir. Clamp the master cylinder mounting flange in a vise and remove the reservoir and two grommets from the master cylinder body. Push the piston in and carefully remove the snap ring. Then remove the primary piston assembly from the master cylinder body. Place the open end of the cylinder bore approximately 25 millimeters or 1 inch from a padded workbench or other surface to catch the secondary piston when it comes out of the bore. Use extreme caution and apply low air pressure very carefully to ease the piston out of the bore. Never point the open end of the bore at anyone when applying air pressure. The piston may come out of the bore with considerable force and cause personal injury. Use only dry, non-lubricated air when removing components. Thoroughly inspect all components for damage and clean them with brake clean or denatured alcohol. Begin reassembly by lubricating the grommets, seals, and the cylinder bore with clean .3 brake fluid. Be sure to use new seals when assembling the master cylinder. Then install the primary seal and retainer on the secondary piston. Next, install the secondary seal on the secondary piston. Ensure that the seals are properly oriented. Install the return spring and the secondary piston into the master cylinder body, followed by the primary piston assembly. Install the snap ring next by compressing the primary piston into the cylinder bore. Now, install two new grommets into the master cylinder and attach the reservoir. Fill the reservoir with clean .3 brake fluid and place the diaphragm in the cover. Finally, install the cover on the reservoir. This master cylinder has been overhauled and is ready to be bench bled and placed back into the vehicle. All General Motors vehicles utilize one of two methods of brake line connection flaring. either ISO, which stands for International Standards Organization, or double flare. This video presentation will only concentrate on the ISO flare technique. Double flare procedures can be found in most service information or the booklet accompanying this videotape. Whenever replacing brake pipe, it is critical to always use double-walled steel brake pipe. Any other pipe is not recommended and may cause brake system failure. To make an ISO flare, the following tools are required: J29803-A, the ISO flaring kit, a hacksaw, a deburring tool, a vise, and a 1 3/8" wrench. To begin, choose the correct size pipe and fittings. Then cut the pipe square and to length with a hacksaw. Correct length is determined by measuring the old pipe using a string and adding 125/1000 of an inch for each flare. Be sure to install fittings on the pipe before starting the flare. Tubing to be flared must have a square-cut end and cleanly deburred inside and outside. Chamfer the inside and outside diameter of the pipe with the deburring tool. It is important to thoroughly flush the inside and outside of the brake line with a non-volatile solvent to remove all contaminants from the cutting and deburring process. Next, clamp the flaring tool body in a vise and select the correct size collet and forming mandrel for the pipe size used. Insert the correct forming mandrel into the tool body. Hold the forming mandrel in place with your finger and thread in the forcing screw until it makes contact and begins to move the forming mandrel. Turn the forcing screw back 1 complete turn after contact is made. Slide the clamping nut over the brake pipe and insert the prepared brake pipe into the correct collet. Leave at least 3/4 of an inch of tubing extending out of the collet. Insert the assembly into the tool body. The brake pipe end must contact the face of the forming mandrel. Now tighten the clamping nut into the tool body. If the clamping nut is not securely tightened, the pipe may push out and the flare will not correctly form. Wrench tighten the forcing screw until noticeable resistance is felt. Do not over-tighten the forcing screw or the flare may become oversized. Back the clamping nut out of the tool body and disassemble the clamping nut and collet assembly. Measure the flare diameter. Depending upon the tube size used, it should fall between 272 and 287/1000 of an inch or 324 and 338/1000 of an inch. When replacing a brake pipe, a tube may have multiple bends and turns. It is very important to not kink the pipe as it is being formed or bent. Also note that 3/4 of an inch of clearance is required for all moving or vibrating parts. The preferred method of brake line forming or bending is using a tubing bender of the appropriate size and a piece of stiff wire. To begin, form the stiff wire in the shape of the line to be fabricated from the vehicle, as the existing line may be bent upon removal. Use the tubing bender to bend the new tubing into the shape of the stiff wire. Move the back plate handle and connecting bar assembly of the pipe bender around the forming head until the connecting bar stops on the holding bar. The handles should form a 90-degree angle. Place the straight tubing between the appropriate sized grooves on the forming head and the holding bar. Rotate the back plate and handle until contact is made with the tubing and the calibration marks align at 0. Note that tube bending will start at the 0 calibration point. Move the back plate around the forming head until the desired angle is attained. Note that slight bending of the brake tubing by hand is acceptable to enhance the final fit. When all the bends are in place, flare the other end of the line. Be sure to install the flare nut first. Install the new brake line, Tighten the fittings, bleed the system, and check for leaks. The brake drum provides a friction surface for the brake shoes to contact. It mounts to the axle shaft and physically stops the axle from rotating. Brake drums should be inspected and measured whenever brake linings are replaced or the customer has concerns of pulsation, chatter, brake sensitivity, brake fade, wheel drag, or a springy or spongy brake pedal. When inspecting brake drums, remember that drums should be resurfaced if taper or out of roundness exceeds approximately 6/1000ths of an inch, or if scoring is in excess of approximately 60/1000ths of an inch. Do not resurface drums due to light scoring or grooves. Brake drums should be replaced if the maximum diameter reading equals or exceeds the discard dimension marked on the drum, or if the drum is under the discard dimension but refinishing would not leave at least 30/1000ths of an inch allowance for wear. It is important to realize that the discard dimension marked on the drum is the maximum allowable wear dimension and not the allowable machining dimension. To set the micrometer to the drum diameter, begin by loosening the 2 lock screws and move both the dial and the anvil along the shaft until the whole number of the drum diameter is visible at each arrow. The metrically graduated shaft has even numbers scribed on one side and odd numbers on the other side. The English graduated shaft has identical scales front and back. Sometimes it is necessary to set a fractional drum measurement with the micrometer. For micrometers with metric measurements, tighten the dial lock screw and slide the anvil end along the shaft in precise 2 millimeter increments. For English versions, tighten the anvil lock screw and slide the dial end along the shaft in precise 125/1000ths of an inch increments. After properly setting up the micrometer, place it inside the drum and across the greatest diameter to be measured. The anvil end of the micrometer is held steady and the dial is moved back and forth slowly to obtain the highest reading. The highest reading is the amount that the drum is oversize or undersize. Always be sure to measure brake drums in 2 or more places to ensure accuracy. When measuring brake drum dimensions, it may be necessary to convert measurements from inches to millimeters or vice versa. When converting from inches to millimeters, the measurement in inches times 25.4 equals the measurement in millimeters. When converting from millimeters to inches, the millimeter figure stamped on the drum divided by 25.4 equals the measurement in inches. A reading of 0.03937 inches is equal to 1 millimeter. Just like brake drums, brake rotors provide a friction surface for the brake pads to contact for stopping the vehicle. New rotors on General Motors vehicles have a surface finish of 0.25 to 1.27 micrometers or 10 to 50 microinches with a non-directional swirl pattern. Although it is not customary to measure the surface finish of rotors, check them for deep scoring, which may require rotor refinishing or replacement. Disc brake rotors should be inspected and measured whenever new brake pads are installed, if the customer has concerns of pulsations or poor brake performance, or after refinishing a rotor. When inspecting brake rotors, remember that rotors should only be resurfaced if there is excessive surface scoring, there is excessive thickness variation, or there is excessive lateral runout. Do not refinish or replace the rotor if the surface has light scoring less than 60/1000ths of an inch in depth. All brake rotors have a discard thickness dimension cast into them. This dimension is the minimum wear dimension and not a refinish dimension. Do not use a brake rotor that will not meet final finish thickness specifications. An accurate micrometer reading is critical to disc brake service. Obtaining a correct micrometer measurement is accomplished by combining 3 readings on the micrometer. The following example will illustrate accurate micrometer reading using an English Standard micrometer. Metric micrometers work similarly. When using a micrometer, always use the calibrated end of the thimble. This end is calibrated to slip when the thimble is adjusted. The numeral scale on the barrel, which measures in tenths of an inch increments, is pulled back to reveal the hole number 2, indicating 2/10 of an inch. The barrel is pulled back to reveal the first segment to the right of the number 2. These individual segments measure in 25 thousandths of an inch increments. The numbers and segments on the thimble measure in 1/1000th of an inch increments. Since the 15 on the thimble is aligned with the horizontal scale on the stem, this indicates 15 thousandths of an inch. By adding each of the individual readings, an overall reading is obtained. 2.0 plus 0.20 plus 0.025 plus 0.015 equals 2.240. Micrometers that measure in 10,000ths of an inch use a vernier scale. To read the scale, identify the vernier number that is perfectly aligned with a thimble number and/or segment. In this case, the 3 on the vernier scale lines up squarely. This equals 3/10,000ths of an inch. Now that we know how to read a micrometer, let's use one to measure rotor thickness and thickness variation. Thickness variation is the most common cause of brake pulsation. Thickness variation can result from several factors, including bound-up calipers, rotor wear due to distortion from improper lug nut torquing, and rotor wear due to lateral runout. To measure rotor thickness, use a micrometer that reads up to 10,000ths of an inch. There are 3 important things to pay attention to when measuring rotor thickness. First, take all measurements within the lining contact area of the rotor. Second, take all measurements the same distance from the outer edge of the rotor. And third, measure rotor thickness at 4 or more points equally spaced around the rotor. Be sure to record each measurement for future evaluation. If any measurement is less than the minimum allowable specification marked on the rotor, replace the rotor. Thickness variations of more than 5/10,000ths of an inch can cause pedal pulsation or vibration during braking. Refinish the rotor to specifications or replace it. Lateral runout is another condition that can result in worn rotors and pedal pulsation concerns. Lateral runout can be caused by improper lug nut torquing or excessive bearing runout. Lateral runout can also be the result of normal rotor wear or improper refacing procedures. When measuring lateral runout on most rear-wheel drive vehicles, tighten adjustable wheel bearings slightly to take out any free play before beginning. Be sure to readjust the wheel bearings correctly after runout measurements are complete to avoid damaging the bearings. For non-adjustable bearings, refer to the service information on end play diagnosis. Begin by attaching a dial indicator to the fixed part of the axle or suspension so the dial indicator tip contacts the rotor face approximately 1 inch from the outside edge of the rotor. Attach the indicator firmly in place so it does not vibrate. Set the dial indicator to 0 and slowly move the rotor through 1 complete revolution while observing the dial indicator. Total dial indicator deflection is the sum of the maximum readings on both sides of 0. Refer to the specific service information for the correct specification. Drum brakes include 2 brake shoes mounted on a stationary backing plate. Return springs hold the shoes retracted. In the duo servo system, A wheel cylinder actuates both the primary and secondary brake shoes. The energizing force transfers from one shoe to the other when the wheel rotates in either direction. In the leading trailing type of drum brake, the leading shoe performs the greater portion of the braking. Leading trailing brakes have a fixed anchor at the bottom of the brake backing plate. On brake application during forward motion, the wheel cylinder forces the leading shoe into contact with the rotating drum. The wheel cylinder also actuates the trailing shoe. Rotational force does not energize the trailing shoe. Advanced leading trailing drum brake operation is the same as the leading trailing design except for the return and hold down spring. Advanced leading trailing uses one component to work as the return and hold down spring. This reduces the number of components needed. Let's take a look at service of leading trailing style brake components. The tools required for servicing this style brake include the brake hold-down spring remover and installer and brake spring pliers. To begin, remove the wheel and tire. Mark the relationship of the wheel to the axle stud. Also, mark the relationship of the drum to the axle flange. Make sure the parking brake is released. If necessary, back off the parking brake adjustment. Some vehicles may require the star adjuster to be backed off. To do this, remove the adjusting hole plug or knockout plate from the backing plate or drum and back off the adjusting screw using a screwdriver and brake adjusting tool. Remove the brake drum next. Tap gently on the outer rim of the drum or around the inner drum diameter by the axle flange if necessary. Use the return spring pliers to remove the upper return spring. Then remove the leading shoe hold-down spring and hold-down pin. The parking brake strut and adjuster assembly is next, followed by removing the adjusting lever from the leading shoe. Now disconnect the leading shoe from the lower return spring. For the trailing shoe, begin by removing the hold-down spring and hold-down pin. Then remove the parking brake lever retaining clip, followed by the trailing shoe. Reassembly is basically the reverse of disassembly. However, before assembling, be sure to clean and lubricate the adjuster screw assembly and verify that the star wheel rotates smoothly. Clean and inspect the backing plate and lubricate all contact surfaces with brake lubricant GM part number 5450032 or equivalent. Also, be sure to inspect all other parts and replace any of doubtful strength or quality due to discoloration from heat, overstress, or wear. After the brake components are reassembled, they must be adjusted. Use J21177-1A, the drum to brake shoe clearance gauge, for pre-adjusting the clearance. Carefully set the J21177-1A so it contacts the inside diameter of the brake drum. Then position the J21177-1A over the shoes and linings mounted on the vehicle. Turn the star wheel on the adjusting screw until the shoes and linings contact the gauge. Reinstall the brake drum, making sure the alignment marks placed previously line up. Do the same with the wheels. Final brake shoe to drum clearance may require an adjustment where the star wheel is backed off several notches. Refer to the service information for the proper procedure. Proper brake lathe operation, whether on or off vehicle, is critical to producing an acceptable rotor surface finish. Therefore, always check for proper operation of all motors, switches, feed controls, and levers. Also, make sure radius cones, bell clamps, and taper cones are free of all nicks, burrs, rust, and foreign debris. Check the arbor for runout. It should have less than 2/1000 total indicated runout. Make sure the bottom of the tool bit holder is also clean, as well as the carbide bit seat on the tool bit holder. If the surface is not flat, install a new tool bit holder. Always follow the lathe manufacturer's specific operating and maintenance instructions for best results. There are 3 basic conditions that are required for a brake rotor to be effective when stopping a vehicle. First, both sides of the rotor need to be flat and parallel. Second, the surface finish needs a roughness analysis, or RA, reading of 50 or lower. And third, the machined sides of the rotor need to be perpendicular to the center line of the hub. Improper rotor refinishing techniques will cause a high pedal effort customer comment. It's important to only resurface rotors when necessary. For example, do not reface new rotors from stock unless excessive runout is apparent. Additionally, do not reface rotors as a routine part of lining replacement unless there is excessive runout, scoring, or thickness variation. Do not reface rotors due to minor surface rust, discoloration, hot spots, or brake squeal. With the lathe properly qualified, mount the rotor and install the vibration dampener. Before mounting either a composite or hubless rotor for refinishing, clean the hat section of all rust, burrs, and any foreign matter. If any debris is present on this surface, the rotor will not reference properly while machining. When mounting a composite rotor, adapters are used to hold it because composite rotors do not have an integral hub. The stamped center must be squeezed, just as it would be when the wheel is tightened against it. Once it is properly mounted, the machining process is just like that for hubbed rotors. With the rotor mounted and vibration dampener installed, bottom the tip of the tool bit in the deepest groove of the rotor. Then zero the scale and back out the tool bit. Repeat this for the other side of the rotor. Move the cutters to the innermost edge of the rotor face. Adjust the micrometer knobs for approximately 5/1000ths of an inch more than the original reading and start the resurfacing operation. After cutting is complete, sand both sides of the rotor with 150 grit aluminum oxide sandpaper to produce a non-directional finish. Use a sanding block and leave the rotor turning at the lathe manufacturer's recommended cutting speed. Sand for 60 seconds. Sanding reduces the peak height, smoothing the rotor surface and increasing the friction area for improved braking. When finished, wipe the rotor clean with brake cleaning solvent and a clean rag. Be sure to check that the refinished rotor meets all inspection requirements. When the driver applies the brakes, fluid pressure behind the piston presses against the caliper piston and the piston bore. The piston pressure forces the pad against the inboard rotor surface. Pressure applied to the piston bore forces the caliper to move on its slides. Caliper movement applies pressure against the outboard brake pad, forcing the pad against the rotor surface. Both brake pads press against the rotor surfaces, bringing the vehicle to a stop. When hydraulic pressure is released, the square-cut seal retracts the piston. This allows the system to reduce brake pad drag, improving brake release and fuel economy. At times, brake caliper overhaul is necessary. For example, brake fluid leaking from the caliper would require this service procedure. Realize that the following procedures for front calipers are the basic steps. Some parts on other front calipers you may encounter may vary from those shown. To begin, remove the caliper from the vehicle according to standard service procedures. Drain the remaining brake fluid into a container and discard it properly. Then clean the caliper of any dirt and grime. Pad the inside of the caliper with clean shop cloths. Remove the piston by gradually directing compressed air into the caliper fluid inlet. The piston will blow out of the housing with considerable force. Be sure to use just enough air pressure to ease the piston out of the caliper. Do not place fingers under the piston in an attempt to catch or protect it, as the piston may be expelled with sufficient force to cause injury. With the piston removed, use a screwdriver to pry the boot out of the caliper. Extend the screwdriver across the caliper bore, under the boot, and pry up. Use care not to scratch the caliper bore or the seal groove. Next, use a small wood or plastic tool to remove the piston square-cut seal from the groove in the caliper bore. Do not use a metal tool of any kind. Doing so may damage the caliper bore or seal groove. Discard the boot and the piston seal. Then remove the bleeder valve from the caliper. After disassembly, inspect the mounting bolts and sleeves for corrosion. Do not attempt to clean corrosion from sleeves and bolts. Replace them if corroded. Clean the parts in denatured alcohol using a bristle brush if necessary. Use dry, filtered, compressed air to dry parts and blow out all passages in the caliper and the bleeder valve. Do not use lubricated shop air to dry brake parts. Drying with lubricated shop air will leave a film of oil on the parts. This may damage the rubber components. Carefully check the outside diameter of the piston for scoring, nicks, corrosion, or worn or damaged plating. If surface defects are noted, replace the piston. This is extremely important as the outside diameter of the piston is the primary sealing surface in the caliper. It is manufactured and finished to close tolerances. Never refinish or use abrasives to remove corrosion on metal pistons. Also, check the piston bore and seal groove in the caliper for scoring, nicks, or corrosion. The caliper bore is not plated. Minor stains and corrosion can be polished away by using crocus cloth. Do not use emery cloth or any other form of coarse abrasive. Thoroughly clean the caliper after using the crocus cloth. If the caliper bore cannot be cleaned up, replace the caliper. Make sure all parts are clean and dry before reassembly. Lubricate the caliper bore and new piston seal with clean .3 brake fluid. Then fit the piston square-cut seal in the caliper groove. Make sure the seal is not twisted. Lubricate the piston with clean .3 brake fluid and install the new boot into the piston groove. Insert the piston into the caliper bore. Be careful not to unseat the piston square-cut seal. Force the piston to the bottom of the caliper bore. A force of 50 to 100 pounds may be required. Be sure not to tilt or jam the piston in the bore. Position the outer diameter of the boot in the caliper counter bore and seat it using the boot seating tool. Note that some applications require that the boot is installed into the caliper bore prior to installing the piston. Check the boot installation. Make sure the metal retainer molded into the boot is not bent and that the boot is seated fully and evenly all around. Now install new mounting bolt sleeves and bushings as needed. Also install new caliper slides if necessary. Then reinstall the caliper onto the vehicle. Before installing the caliper, clean the contact surfaces with a wire brush and smooth any deep nicks or gouges with a file. Then install the caliper and measure the clearance between the caliper and mounting bracket with a feeler gauge. Total clearance should be 10 to 24 thousandths of an inch. Also, clearance should be consistent from top to bottom. Clearances may vary, so check the service information for the correct specification and make any necessary adjustments as described. Realize that improper caliper clearance can lead to customer concerns. For example, if the clearance is excessive, a rattle sound can be heard from the front brake area. If the clearance is too little, brake lead and excessive pad wear may result. Additionally, on calipers that use machined guides, be sure to measure the caliper slide clearance. Check the service information for adjustment procedures. This special Certified Plus training presentation is a prerequisite to the Training Center Hands-On Base Brake Systems course number 15,000.01. Properly performing all base brake repairs is critical, not only to customer satisfaction, but to overall customer vehicle safety as well. Get the training you need and use the resources available, such as the booklet that accompanies this videotape, to ensure your status as a service expert.